Here we go, everybody, off to section 3.2. Section 3.2 is entitled Quadratic Functions. So a quadratic function is a polynomial function. It's a polynomial function that has degree of 2. So it can have several different forms, and each form has a certain advantage. So a quadratic function has the form f of x equals ax squared plus bx plus c. This is called standard form. Or f of x equals a times x minus h squared plus k. That's called vertex form. Or f of x equals a times x minus p times x minus q. This is going to be the intercept form. Okay, the intercept form tells us the x-intercepts. So the x-intercepts are p comma 0, q comma 0. Vertex form tells us what the vertex is. So the vertex is going to be h comma k. All right? So those are the three different forms for quadratic functions. So let's practice going from one form to the other. So if I asked you to do this one, we want to write y equals x to the second plus 4x minus 5 in vertex form. Okay, so here we go. What we're going to do is we're going to start this. We're trying to get it into some kind of binomial squared plus or minus some other number on the end. So what I'm going to do here then is I'm going to write this as x squared plus 4x, and I'm going to leave a little space between the 4x and the negative 5. Because what I'm going to do is I'm going to add something here in order so that this trinomial is a perfect square. So it could be written as x plus or minus something in parentheses squared. So I take this 4 right here, this 4 from in front of the x, and I divide it by 2. And then I square it. So 4 over 2 is 2. 2 squared is 4. And that's what I'm going to add then right here. I'm going to add 4 right there. So let's see, I'm going to make that a, shade it. I'm going to shade that. And then if I add 4 there, in order to keep it balanced, I'm going to have to subtract 4 over there. Okay? So you add 4, subtract 4, so you've essentially added 0. So that's a legal algebraic move. So that plus 4 there next to the x squared plus 4x completes the square. All right, so I end up being able to factor x squared plus 4x plus 4 into x plus 2 squared. And then I got the negative 5 minus 4 is negative 9. Okay, so that tells us the vertex then, right? So that tells us the vertex. So the vertex is negative 2, negative 9. All right? Remember, in parentheses, you look at it as the opposite, just like those circles. All right? So that's a type of problem you'll see, is to rewrite something in standard form as a vertex form. If you want to write it in intercept form, you just try to factor it, right? We're just going to factor that polynomial. All right, let's do another one. So let's check out this one right here. So write an equation for the parabola with y-intercept of 0, 2 and x-intercepts of -3, 0 and 2, 0. So I'm going to use the intercept form for this one because we have the intercepts. So I'm going to look at -3 as my p in that intercept form. I'm going to look at 2 as my q. So then my formula for this one's going to be f of x equals a times x minus p, so x minus -3, times x minus q, so x minus 2. And you look at that one, you're like, okay, I don't know what a is. Well, that's 0, 2, I guess it was -2 in the notes. 0, -2, I'm going to plug 0 in for x, and I'm going to plug -2 in for y, and that's going to help me figure out what a equals. So -2 in for f of x or y. A is what we're trying to find. This is x plus 3. Actually, I'm plugging in for x as well, right? I'm plugging in 0 for x. So 0 plus 3, 0 minus 2. So that I get -2 equals a times 3 times -2. So -2 equals -6a. So a is 1/3. -2 divided by -6 is 1/3. So my final answer, f of x equals 1/3 times x plus 3 times x minus 2. That would be our final answer for this one. Okay, so I got one more to show you on this section. This, of course, should be a review because we did in Math 95 and in Math 65, we did a lot of work with parabolas, right? And that's all this is a parabola. Okay, the last one. I have an example where you're given the height of some, I don't know, you throw a melon up in the air or something, -4.9 t squared plus 316 t plus 423. That is going to be our height formula. So height in t seconds of some projectile is given by that formula. For those of us that have had physics before, you should notice that -4.9 is half of gravity in the metric system, right? Metric system gravity is -9.8 meters per second squared. All right, so we're being asked how long does it take for this whatever to splash down? How long until object splashes down? And then how high does the object get? We're in meters here because it's the -4.9 t squared. So we're going to be in meters. And then the time is going to be in seconds. So we're going to go over to Desmos and we're going to plot this function. All right. So I can use the same exact notation. I could use h of t equals, then I just plug it in, -4.9 t squared plus 316t plus 423. So you look at that and you're like, I don't see where the rocket's splashing down, nor do I see how high the rocket gets. So we got to zoom out here. So just start zooming out. Oh, it looks like you can't go backwards in time. Einstein proved that, so we can't say -1.31 seconds when it splashes down. But right here, that is the answer for how long it takes to splash down. So 65.80172 seconds. So let's write that down. So it splashes down at t equals 65.802. and then we got to figure out how high it gets. So we're going to go back to Desmos, and then we're gonna have to get to the top here. A couple different ways we could do that. One, we could keep squeezing in until the top kind of shows up, right? Or we can go over here to the wrench, and I know I got to get way higher on the Y. See, the Y goes up to 2,500 right here. So I could switch that to like 5,000 and see what, I guess I switched it to 59.99. Well, that works because it actually gets higher than 5,000 meters. So we look at that, and it looks like I got 5517.694 meters high. So I go back to my open math, and I type that in, and hopefully we got it right? 5517.694 meters high. It's way up there, right? Okay, so that, everybody, is the quadratic function section. Pretty short section. And I'll see you on the other side in 3.3.